we're going to download the software, you want to do a Google search for Visual Studio Student version. And it should be one of the first results that comes up. The web address is https://visualstudio.microsoft.com/downloads/. So you can type in the web address or just do a Google search. And you'll be brought to this page. We're going to download Visual Studio 2017 Community version, which is the free download. And your download should start automatically. When that's complete, you will run this software. And you will allow it to make changes. Click continue. And your download could take a little longer than this. I've already downloaded the software. Once you see this page, we want to make sure that we are installing all of the necessary optional software. And so you want to make sure that .NET Desktop Development is checked, as well as Universal Windows Platform Development and Desktop Development with C++. Now over here on the right, you will see those same titles. Under .NET Desktop Development, the optional software, you want to make sure that the first 5 are all checked. And under Desktop Development with C++, under Optional, you want to make sure that these first 8 are checked, down to Test Adapter for Google Test, and also the C++ /CLI support. You want to make sure that those are checked. And under Universal Windows Platform Development, under Optional, make sure that C++ Universal Windows Platform Tools is checked, as well as Graphics Debugger and GPU Profiler for DirectX. Make sure that those are all checked. When you check those, you'll have the option here to click Modify. I've already installed this software, so it's not giving me that option. If I check something extra, you see it changes to Modify. And after a second, it will allow me to click. So I'm going to uncheck that. And I'm going to close this. I've already installed the software. When you click Modify, this part of the download could take several hours. You may want to do this overnight. So I'm going to go ahead and close this. Once the download is complete, you're going to want to click Launch. You can also launch the software, of course, by doing a search under your Start button for Visual Studio 2017. And you might want to pin the software maybe to your taskbar or as a desktop icon. When Visual Studio launches, it looks something like this. You want to scroll down here in this main window, and we're going to choose Create New Project. So I'm going through here, you have to do these steps every single time you start a new project. So every new program that we write, we're going to have to follow these steps every single time. So you'll want to maybe take some notes of exactly what we're doing here. When we start a new project, under Visual C++, we want to select CLR, and we're going to create a CLR empty project. Now, you want to save your project in a location that is of your choice. You want to click Browse, and I have folders for all the classes. I'll save it in the appropriate folder. I have a folder specifically for my projects. So this is the folder that I'll select. And then I want to give my project a name, and you can name it anything that you want, as long as there are no spaces and there's no special characters, and it can't start with a number. And so I'm going to call mine first project, and I'm going to click OK. And so again, no spaces here, no special characters, cannot start with a number. The capitalization of every word is a convention for programming that you will want to follow. That the new project has been created, there's several more steps that we need to go through. And again, you have to do this every single time you create a new project. We're going to start by clicking on Project. We're going to add a new item. And under Visual C++, you're going to click on UI, which is the user interface. We're going to add a Windows form. By default, the name of the Windows form is myform.h. You can change this name if you want. but same rules apply. No spaces are allowed, and it cannot start with a number, and there can't be any special characters. You want to make sure it ends in .h. I'm just going to leave it as my form. I'll click Add. So you'll see that when the form has been added, you'll see that it comes up with an error. And so again, there's still several more things that we need to do before we can start our programming. What we want to do now is here where the title of your project is, I named mine First Project. You want to right click this. Oops. And you want to go to Properties. And under Linker, under System, the subsystem, if you click this drop down arrow, one of the options is Windows. And so it says Windows in parentheses / subsystem : Windows close parentheses. So you want to make sure that it's set to be Windows. Also under Linker, you want to go to Advanced, and here at entry point you'll have to type in the word main, M-A-I-N, all lowercase, no spaces, no space at the end even, and you'll click OK. Now we want to go to myform.cpp. We want to double click this. And you'll see there's some code already written here. The # include in quotations myform.h. There's some more code that we need to add here, and again, you have to do this every time you start a new project. And so what I do is I keep this code saved in a notepad document or a Word document. This will be available to you in Canvas. I'm just going to copy this right out of this document. But notice that I'm not including that first line, the # include myform.h. That's already there. I'm just copying everything below that down to the closed curly bracket. So I'll copy that, and I'll paste it right here at line 2. Now by default, the program wants to name your project Project 1. We named, or I named my project anyway, First Project. So I'm going to change this here to say First Project. Okay, and then here under myform.h, you want to right click this. You want to go to Properties, and where it says Exclude from Build, you want to select No, and under Content you want to select Yes, and you'll click OK. Okay, now the play button for the program, or the debugger button, is right here. It says Local Windows Debugger. It's a triangle, looks like play. If you click this, it runs the program. It compiles the code, and it runs the program. Okay, and here you can see the program running. Right now it's blank. There's no buttons or text boxes or anything, but it did run, and so there were no errors. So everything looks good so far. We can close this. And now if we look at the myform.h designer, you can see this error is still here. Go ahead and close this tab. And over here in the Solutions Explorer, under myform.h, you want to right click, and you want to click on View Designer. Now when the designer opens, the error is gone, and we can start working on our program. And so we're going to write a simple program. It'll take in 2 numbers, it will multiply those numbers together, and then display the results. And so I'm going to look back at my notepad document here. Anytime we write a program, we're going to follow the 4 steps of program development. We're going to start by analyzing the problem. The problem is very simple. Take in 2 numbers, multiply them, and then display the results. So not a lot to do there. Second step is the design, and the first step is to do the interface sketch. And so by this they mean they want you to sketch it out on a piece of paper as to what it might look like. Our program is fairly simple. I'm just going to go ahead and create the interface. And so the interface right now is blank, and over here in the toolbox you'll see all of the different tools that you can add to this form. If you don't see the toolbox, you should see a icon right here that says Toolbox, and if you click this, it will open the toolbox. If you don't see this icon, you can click this drop down arrow, add or remove buttons, and make sure that the toolbox is checked. Also make sure that the properties window is checked. And so the properties window should be here somewhere. Again, if you don't see it, the button looks like a wrench. You should be able to add the properties. If you don't see the wrench, you can add the wrench to the toolbar. Okay, so under the toolbox, I'm going to start by under Common Tools or Common Controls. I'm going to scroll down and I'm going to find the label. I'm going to add a label to the form. I'm going to look back in the toolbox and scroll down. And I'm looking for the text box. I'll add a text box right here. Then I want to add another label somewhere about here, and add another text box about right here. And then I want to find the button. I'm going to add a button to the form. Center that. And then I'll add one more text box. Okay, and the form is a little bit too large. If I click on the form, the grips will appear and I can resize the form itself. Be very careful not to double click anything on the form or the form itself. Okay, don't double click anything unless told to. Notice that the labels, they say label 1 and label 2. If I click on label 1 here under the properties window, it says label 1, which is the name of the label. That's how the program recognizes that label as label 1. The text, though, is different from the name. By default, they're the same, but the text is what the label actually shows. And so I'm going to change the text to number 1, press enter, and you'll notice that the text of the label has changed. Again, the label is still named label 1, but I've changed the text. If I want to change the actual name, I can do that as well. If I scroll down to design, I could change the name to whatever I want, as long as I follow those rules. Cannot start with a number, no special characters, no spaces. It can have an underscore. So I'm going to do the same for label 2. I'm going to change the text to number 2. And also the button. I'm going to change the text of the button to say multiply. I'll capitalize that. Okay, and so the idea of the program is the user will enter a number in each of these two text boxes, click the button, and then the answer will be displayed for the product of those two numbers. And so if I go ahead and click play now, the program runs, we see that the program now has our labels and our text boxes and our button, and so this is the program running. And so if I type in something like 2 times 3 and I click the multiply button, you'll see that nothing happens. We haven't told the program what to do yet. It doesn't know what we want. And so in fact I can even type in any number here in this text box that I want. And so I'm going to go ahead and close the program. It's a good idea to test the program multiple times as you're writing the program. Make sure that it still works. If you encounter any errors throughout the program, it's much easier to fix them periodically rather than all at once at the end when you find out that the program doesn't work. And so, looking back at my Notepad document here, we've designed the interface, right? We've put the buttons and the text boxes on the form. Now we need to develop a solution strategy. And our solution strategy is almost always going to be these 4 steps. At a bare minimum, it has to be these 4. It could be much more complex than this, but these are the steps that we need to follow. We need to always start by declaring the variables. Then we need to read in the data. Then we will process the data, and then we'll display the results. And so this is the part where we're ready to start writing the code. And so to do that, now you want to double click the button. Okay, double click the button. When you do that, myform.h tab opens, and this is all of the C++ code associated with our program so far. And so I'm going to scroll up a little bit and just show you. This part of the code is in reference to the form itself and the controls that the form has on it. And then every control has its own set of little code. This was all automatically generated for us. Obviously I didn't type this. This was automatically generated as we added the text boxes and the buttons to the form. And so that's what the code is that you're looking at here. This is all automatically generated for us. when I double click the button, this line of code was added automatically, right? So when I double click the button, this was added for me. This is called a method. Specifically, this is called an event handler. And so what this line of code says is that when button 1 is clicked, which is the name of my button, when button 1 is clicked, this is the code that is going to be executed, and this is the code that I'm about ready to type. You'll notice at the end of the line here there's an open curly bracket. I like to put my cursor to the left of that and press enter. Then put my cursor to the right of that curly bracket and press enter again. Any code that I type in between these two curly brackets is the code that will be executed when button 1 is clicked. Okay? And so this is where I'm going to start typing my code. If I type in 2 forward slashes, that allows me to write a comment. So anything that I write after the forward slashes on that line is not part of the code. Rather, it's a comment for human beings to read and try to better understand what the program is doing. So if I write this program and someone comes back later and needs to edit my program, the comments are going to help them decipher what my code is doing. And so in my comments, I'm going to start by saying I need to declare the variables. Right, that is the first step. So back in my text document here, first step of my solution strategy is to declare the variables. And so our program takes in 2 numbers, multiplies them, and then displays the answer. I'm going to need 3 variables to do that. One to hold each value that is going to be multiplied together, and a third one to hold the answer of that multiplication. So to declare a variable, there are different variable types. I'm going to use integers. I'm going to start by typing int. This tells it that I'm going to be declaring a variable of type integer, and then I give the variable a name. I can name it anything that I want. Same rules though, no spaces, no special characters. Can't begin with a number, but can have an underscore in it. It can start with an underscore, as a matter of fact, just not a number. And so I'm going to name my first variable num1, and then every line of code that I type has to end in a semicolon. I'm going to declare another variable. I'll name this one num2, and a third variable, I will name it num3. And so declaring these variables allocates space in memory to store the data that these variables are associated with. That's what declaring the variables does for the program. And so we've declared the variables. The next step now is to read in the data. And so what that means is num1 is allocated space in the memory, but it's not currently holding any data. That data comes from the text box on my form. And so this text box is where the data comes from that is going to be stored in the variable num1. And so this text box is named textbox1, right? That's important. And so back in my code here, my form.h, I'm going to now read in the data. So the code to do this, I've also put in this text document, is int32 : tryparse, textbox1 dash greater than symbol text comma, and then the variable name, close parentheses, semicolon. And so I'm going to copy this out of here and paste it into here. So I'm going to copy this out of here and paste it into here. And so textbox1, that's okay. That's where the information is actually coming from. And so what this code says is tryparse means that when the user types in 3 into the text box, the 3 is a character, right? It's an Arabic numeral, but the computer does not really think of that as the value of 3. And so tryparse takes the character 3 and converts it to an actual numerical value that represents 3, which would be a binary number. The computer remembers that as a binary number. So tryparse converts the character 3 into the value of 3. The data is coming from text box 1, specifically the text of that text box. And that data is going to be stored in a variable. And so variable here is just a placeholder. I need to erase that and type in num1. That is the variable where the value that is in text box 1 will be saved to. And so if I go down to the next line, I'm going to paste that same line of text again. This time though the data comes from text box 2, so I change this to 2. And the value from text box 2 is going to be saved in the variable num2. So these two lines of code are reading in the data. Where does the data come from, and where is it going to be stored? The next step in the strategy here is to process the data, which means to actually multiply them together, right? That's how our data will be processed. So we're going to process the data. And so what I want to say is that num3, the variable num3, my integer variable, is going to be equal to whatever num1 was times, and I use the asterisk for times, which is shift 8, num2. And then again, I have to end my line of code with a semicolon. And so to process the data says that we're going to multiply num1 and num2 together, and whatever that value is, we're going to store that value as num3. Okay, and then the last step is to display the results. And so to display the results says to take the value, the numerical value that is stored in a variable, convert that to a string or a character, and display that back in the text box. And so the code to do that is this last line. I'm going to copy and paste this here, and I'm going to go ahead and put the comment here to display the results. Display the results. And so the line of code says that the text of, in fact it's text box 2 here is what's in the notepad document, but I actually want to say text box 3. Right, text box 1 and 2 is where the user data came from, and text box 3 is where the result will be displayed. Right, this is text box 3 right down here. That's text box 3. So the text of text box 3 will be the variable, which is going to be num3. Right, that's the variable that holds the solution to the multiplication problem. And that value is going to be a binary number, and it has to be converted to a string. So that's what the .toString parentheses, and then every line ends with a semicolon. That's what the .toString means, to convert that binary number to an actual numerical value. And so now we will press the play button again. And now when my program loads, I should be able to type in two numbers, like 2 and 3, and when I click the button to multiply, the answer of 6 is displayed. And I can type in any numbers that I want here as long as they are integers, 4 and 3, or how about 4 and -3, because -3 is an integer, and so the answer is -12. What won't work though is because I declared my variables as integers, I should not be able to use decimals, like 4.2 times -3. You see the answer came up with 0. I believe the program probably encountered an error when it tried to do that, because the variables are not set up to hold decimals. They are integers only. And so as long as I use integers, I can multiply any two numbers together. 256 times, I don't know, -128, -32,768. There is a limitation though. The integer type data, it can only be so large, and so for example, if I do something like 1,000,000 times 1,000,000, now when I multiply, you see that the answer comes up as -7 something, and so that's obviously not the right answer. This was a limitation because the integers can only hold values that are so big, and so the answer here is a number that is bigger than the integer data type can hold. And so one last thing real quick, if I were to look into the folder where my project is saved, under debug, these are all the files associated with my first project program. Under debug, you will find the first project application here. And before I look at that, let me make sure that I do a save all on my program. And so this saves all of the files associated with my program. And so the myform.cpp, we typed in some code here. myform.h, we typed in some code here. We designed the form. All of these files are associated with my program. And so a save all saves all of those. Now when I look at the debug folder of my first project, the first program application is actually the application. I can send this to my desktop and run this program straight from the desktop. I could compress it in a compressed folder and email it to someone else, and they could download the program and open it and run it the same way that I'm running it on my own computer.